So this is going to be a little bit of an overview of some sort of neurological integration moves. A lot of this came from some of the pediatric courses I took in chiropractic school. So basically, we're going to start out with the smooth pursuit pattern on vision, usually on our back. We're just going to go through our typical H pattern. You can go through some diagonals too, whatever you want, just to get a baseline on do we have good visual tracking or not. If we don't off the start, we can also throw a little bit of convergence into that too. We want to see at what point does vision double, or if they come in and hold, which eye lateralizes first and kind of fatigues out. So once we get a baseline on that, we start to add in a little bit of intrinsic activation. Either like we can do it as basic as kind of wiggling the toes or like wiggling the fingers. So now I'm going to add, like, let's say my left hand up, wiggle my fingers, then I'm going to do my visual tracking each way. And what I'm going to look for is as I'm wiggling is, let's say when I go from either right to left visual field, does this start to slow down a little bit, then speed back up? Because to move this left hand, I'm going to be using my right-sided descending cortical control to say wiggle those fingers. So as I move my finger back and forth, when I'm getting to my right visual field, that's going to crash over to my left occiput. When I'm going to my left visual field, that's going to flow over to the right occiput, or the right occipital lobe. So I want to see, can the descending right cortical control to the left side of the body play nice with visual input going from either visual field to either side of the occipital lobe. Then I can do it with, let's say, a little bit of toe wiggle. So I can wiggle toe, same thing back and forth, then start to go contralateral. Like, let's say I can wiggle my left toes and my right toes and my left fingers, same thing. See if they start to slow down or discombobulate at one side and come back on the other. So now I'm looking at both sides of my cortex, telling some things what to do. From a motor standpoint, as I'm bouncing back and forth on visual fields. We want to see which one of them kind of blow out and makes everything stop working. So is it, when I have the same side working together and I get to the opposite and I get to the opposite visual field, or the same side? So like right now I'm going to be using my left higher brain centers to say I want to move the right side. So when I get over to my left visual field, and that's going to float sort of towards the right occipital lobe, do those two not like to work together whenever you've got this little cross going each way of what's going on? So basically we can do this, and the test is also partly the exercise. This would be just to fatigue out. If I was not good at left toe and right fingers, I'd be doing that with a nice, slow, smooth pursuit. I could do a little bit of convergence stuff on that also, just to see, can I start to improve that and get everybody on the same page? And we're sort of just looking for how many levels of complexity, or is it ipsilateral contralateral pattern? Is it more upper body, lower body? And is that specific to a certain visual field? When something's got to give. Like when I go to my right visual field, is my left lower body gonna kind of lose a little bit of coordination, but the upper body kicks on? So one of those different ways to look at the body and put things together. Give it a shot, see how that goes, and have a great day.